Alright, we're going to talk about neutralization reaction. And if something's neutral, when we look at the pH scale, and I'm just introducing the pH scale to kind of show you acids and bases and what they are. Okay? Now, some of you have seen the pH scale before, a long time ago. They're in textbooks. We haven't dealt with it in here. Now, we've dealt with acids, naming acids, right? You guys all know how to name acids, write formulas for acids. If you don't, you'll quickly remember how to do that, because you might have to do some of that. So we have what's called a pH scale. In 7, like today in the other in the other chemistry class, we're going to go ahead and use a pH probe. And the pH probe will indicate, just like temperature does, how hot or cold something is. A pH probe tells you if it's an acid, if it's a strong acid, if it's a weak acid, if it's neutral, base, if it's strong base, weak. So if it ranges from 0 to 7, then 0 to 7 is what we call an acid. Okay? Alright, 0 to 7 is an acid. Now, down here, it's strong. Now, you guys won't have to know that right now. Later on, we'll reintroduce this to you. But 0 is strong. Where it gets close to neutral, it's weak. Okay? So, those type of acids would be like HCl, HNO3. Right, so those are acids, and we could list a bunch of them out. On the right side, we have things that if they're above 7 on the pH probe, it reads that. Then those are called bases. Okay. A common acid would be vinegar, lemon juice. Anything that's sour tasting, has a fruit that's sour tasting, citric acid. It's an acid. Bases are bitter. There's not too many things that are bitter, like if you eat fruit before it's ripened, that's bitter, like a banana. You eat a green banana, that is bitter. Okay? So a lot of things that are vegetables or some other things that they have bitter taste to them. Now bases are going to be such things as hydroxides. It's going to be like NaOH, KOH. Those are considered bases. Now, why are we talking about acids and bases? Because when you put equal amounts of an acid, equal strength acid, concentration, with an equal concentration of a base, they are going to react to make water and a solution of an ionic compound. So we're going to make salt water, basically. We'll just make salt water. That's all we're going to make. And so if it's salt water, since it's water with salt dissolved in it, that's neutral. So water is neutral. So how do we know we got a new product? Because we start out with solutions that are aqueous and we end up with liquid water when we're done. So we end up with a new product. It's just not a precipitate like we've done with our other double displacement labs. Okay? Reactions. So we're going to run through a couple examples. If you want to write down the first one, well, I'll do that one with you. Just discuss it. Then I'll have you do the next two to see if you do them right. And then we'll go to your lab and we'll talk a little bit about the lab. So this probably will take 7-8 minutes. After that, you will work on your lab, probably get it done, and hand it in, so you won't have it late or anything. It's not due until tomorrow, but most of you want to get it done and hand it in so you get it up, get that taken care of. So the first one is a double displacement. Hydrogen's kind of like a metal. It's over in that alkali group, similar to it. So H will come in and replace the Na. The Na will take the place of H. So it's kind of like a double switch. So we make HOH. We don't write it as H2H. We write it as H2O. And then what's left over is your salt in ACl. And we know all chlorides are soluble on that solubility chart, so that would be AQ. And if you go through it and make sure you balance it, I noticed on the last lab that some students forgot to balance their overall reaction. They had the solid right, they had their formulas right, but then to be a true equation, it has to be balanced. So make sure, after going through and doing all that work, like we just did here, that you balance it. Okay, you balance the overall reaction. So go ahead and do the next two. Shouldn't take you too long. It'll be really similar, and then we'll see what we end up with for our answers. If you would do that, we'll check that out. Okay, now that you've had time to look at that, the K will replace the H. So we end up with, again, H2O. We'll always end up with water. When we have an acid and base that we're reacting. And then the K will go with the NO3. And we know all nitrates are soluble according to our solubility chart. And so that's what it would look like. Any questions? It's just a double displacement. This one's a little different. You're going to have to balance it. So again, don't take the 2 with the H. Okay? Now, it might work out to where the 2 will be on the side, but don't take the 2 with the H. Okay, necessarily. Alright? So we're going to put, well, you're going to have to, I guess, because we know we form water. So I take that back. Most of the time we don't say take the subscript, but since we know H goes with OH, we got HOH, which is H2O. Again, we just get water. Plus, we end up with LiSO4. Remember, we take just one of each, then we balance out the charge. So Li is a +1, the sulfate's a -2, so it's Li2SO4. And sulfates are soluble, so that would be AQ. Okay, so Li2SO4. Now to balance it, I should just have to put a 2 in front of LiOH and a 2 in front of H2O. Okay, so it's H2SO4. I have 4 hydrogens on both sides. So we have 4 on the right, left. Oxygens, if I'm looking at the oxygen in LiOH, there's 2 oxygens and 2 in water. I've got 1 sulfate and 2 lithium, so everything's balanced. Okay? So those are neutralization reactions. The last thing I would like to discuss with you has to be with the single displacement lab. Alright? So we're going to discuss that here in a second. If you have that out, we can look at the first result that you have dealing with magnesium and H2SO4. So did we have a reaction in that part of our reaction table? So when we put magnesium with H2SO4, so when you read across the top, magnesium is not going to go with magnesium nitrate. But when you put magnesium with H2SO4, did you get a reaction? Yes. So then we do a single displacement. Mg replaces the H2. Now you can write this on the back. I told some of you before you left that you don't just have to answer the questions, but you're going to have to write out each reaction that happened. So this would be maybe one you could write out. So Mg is going to go with SO4. The charges balance out. It will be aqueous. Plus, we form H2 gas. Hydrogen gas. Hydrogen has to be diatomic, right? If we're going to set up a reactivity table, so I'm going to refer you to the bottom of your lab where it says for you to write out the order from most active to least active element. Okay, see that on the front sheet? You may want to wait and do that part of the lab at the very end. Okay? And this is why, because you can write all your reactions out and see what can replace what, or what replaces what. So, if I had an activity table, okay, to kind of see what elements tend to be most active, that's what you're going to do based upon your results. Would magnesium be higher or lower than hydrogen? Higher. Because why? Because it took the place of hydrogen. It was more active than hydrogen, and hydrogen had to be replaced. Okay? So we put Mg above H. But we have 4 other elements that we have to consider in this list. So that's what you're going to have to do. Okay? You can look at this 2 ways. You can look at if magnesium, if it reacted and we have a product, the element by itself is more active than the element that it replaces. So it would be higher on the list. You can also look at it this way. If hydrogen is replaced, it's lower on the list. Does that make sense? If something is taken the place of by something else, some other element, it means that it's lower on the list. So there's a tendency for students to look at the solutions and realize, oh, look at all the silver. They're all reactive. That's got to be at the top of my list. And that is the opposite thinking, right? Because what's happening to silver every single time? It's getting replaced. So definitely silver is not going to be at the top of your list. It's always replaced. Okay? So think of that when you do it. If it's replaced, it's lower on the list than that element that it's pairing up with. And so hopefully that'll allow you to do your list, and I gave you some really good hints. So it shouldn't be that tough to kind of put them in order based upon your results. Now I've had students look out of the book, and they just copy what's in the book. And then they have some reactions that were wrong and false. But you got to base it upon your reactions. You can't base it upon looking in the book. So don't look in the book. Base it upon your reactions and how they worked out. Okay. All right, you guys can go ahead and work on those things.